Hello class, welcome to this video on the chapter 5 for geometry. So we're looking at rotations, translations, reflections, and we're also looking at the stuff for chapter 5, which is related to triangles, angles, things like that. So let's look at translations. So it says, what is the image of P of -5, 11 along the vector 3, -8? So all you need to do is just do what the vector says. It says +3 and -8. So that means you're going to move to the right 3, move down 8. So you're just going to add 3 to the x coordinate and then subtract 8 from the y coordinate. So we got here, I'm just going to add that and then you're going to subtract. Okay, so we got -5 plus 3. All right, so -5 plus 3 is -2, and then 11 minus 8 is -3. Okay, and that's it. That's all you got to do for the first question here. All right, so for the next one, write a set of coordinates that models the image of the triangle after translation x minus 1, y plus 8. So you just got to subtract 1 and then add 8. So the coordinates of A are -4 and 2. And so, well, let me just do it over here. So you got A is -4, 2. B is -1, 7. And then C is 0, 3. And so all you got to do is, again, I'm going to the translation, x minus 1 and y plus 8. So really you're taking away 1 and you're adding 8. Okay, so -4 minus 1 is -5. And then 2 plus 8 is 10. Then you got -1 minus 1 is -2, 7 plus 8 is 15, 0 minus 1 is -1, and then 3 plus 1 is 3 plus 8 is 11. All right, and that's your coordinates A, B, and C. So we can put our answers there. All right, that takes care of number 3. So let's look at rotations. So what are the coordinates of the image of B1, -5 after a clockwise rotation of 90 degrees about the origin? All right, so the rule for rotation clockwise about the origin is y -x. Okay, so that's your rule. Okay, so then we can go ahead and apply that rule. We just got to do it to B, right? So B is 1, -5. So if I apply that rule, I have to switch the 2 coordinates, right? And then put a negative on the second coordinate. So this is going to turn into -5, -1. All right, that's it for part A. On part B, 180 degrees rotation. So the rule for 180 degrees is -x, -y. So you just put negatives on it. So B, which is 1, -5, is going to transform to -1, +5. That's it. Just put negatives on both of these. But if I put a negative on 5, then that's going to, if I put an extra negative on -5, that turns positive. All right, and then the rule for rotating clockwise 270 is -yx. So you just have to know these rules, right? So for the test. So now we got 1, -5. That transforms into, switch the 2 coordinates and put a negative on the first one. So it's going to be 5, 1. All right, takes care of that one. Number 5, the coordinates of triangle ABC are given, A, B, and C. The triangle is rotated 90 degrees counterclockwise about B. What are the coordinates of A prime, B prime, and C prime? I'm going to draw the triangle as well. So we got -1, 1, 2, 3, 4, 5. We got B is 1, 2, 1, 2, 3, 4, 5, 6. And this should say -3, 2, not -3, 4. Okay. So we need to change that. Okay, so now this is the most difficult rotation question, is because this time you're rotating 90 degrees counterclockwise about B. Okay, so before we were doing it about the origin, right? The origin is this middle point, right? But now this time we're trying to rotate about B. Okay, so I'm going to put that point in red. So what we need to do first is we need to take that point B and move it to the origin here. Okay, so I'm going to move it from, I need to move that point from there to there. And so that means I need to move it down 1, 2, 3, 4, 5, 6, and over 2. Okay. Now, if I move that down 6 over 2, I got to do that for A and C, right? So I got to do that for all of them. So first things first. The first step is I move it to the origin. Second step, I rotate using the rule for rotation 90 degrees counterclockwise. Let me write down the rule for 90 degrees counterclockwise. So 90 degrees counterclockwise is negative yx. Okay, so I move B to the middle, and then I use this transformation rule, and then I move B back to where it was. Okay, so that's what I'm going to do. All right, so first step, we got A prime, or no, A is -1, 5. Then we are going to move it to the left 2 and down 6. Okay, so and we're going to do that for all these. Okay, so if I do -1 minus 2, right, I get -3. 5 plus -6 is -1. We get 2 minus 2 is 0. 6 minus 6 is 0. -3 minus 2 is -5. 2 minus 6 is -4. All right, so next we're going to do the rotation, okay? So rotate 90 degrees counterclockwise. And we're applying this rule. So again, you got to switch the coordinates and then put a negative on the first coordinate after you switch it. So I got to switch these. So -1, -3. Then I put a negative on the first one, so that turns into +1. 0, 0 is still going to remain 0, 0. Now for this one, switch it, so it's -4, -5, but then put a negative on the -4, which turns it positive. That should say -5 right here. All right. And then now, finally, we've rotated it. And now we want to move it back. Okay, so now we want to move it back to where it was. So I got to go +2, 2 to the right, and then 1, 2, 3, 4, 5, 6 up. Okay, and that'll take B and put B back where it was. Okay, so that's what we're gonna do. So we got to do +2, plus 6. You don't have to put the pluses there. I just did that for emphasis because they're positive anyways. Okay. So here we go. We got 1 plus 2 is 3. Negative 3 plus 6 is 3. And we got 0 plus, so this big split goes back to 2, 6. 0 plus 2, 0 plus 6. And then 4 plus 2 is 6. Negative 5 plus 6 is 1. All right, so those are your coordinates. And let's graph them to see how it changes the answer. So let's see what the final answer looks like. Okay, I'm gonna do that in green. So we got 3. Now I'm gonna just erase this so I can draw the picture. So we got 2 comma 6. We got 3 comma 3. And then we got 6 comma 1. Okay, and there you go. That's what we got. So basically I took this and I rotated it 90 degrees. All right, and then that's what I get. So it rotated 90 degrees, counter, and there you go. So I took it and I rotated 90 degrees counterclockwise. That's counterclockwise right there, okay? All right, so there's number 5. So let's look at so now we're going to say what quadrant is each point located after the rotation. All right, remember that this is quadrant 1, 2, 3, and 4, right? So it looks like all the points are now located at quadrant 1 after we do the rotation. All right, there you go. All right, so let's look at sequence of transformations. So now we're going to have multiple transformations. Which of the following transformations would preserve distance when applied to the pre-image? Preserve distance means the distance doesn't change. So if I take a triangle and I move it, right, from one place to another, that is not going to change the distance, right? It's going to preserve the distance. So therefore, translation preserves distance. If I take a triangle and I reflect it or flip it, it's still going to preserve the distance, right? It's still going to be the same size triangle. So therefore, reflection preserves distance. It doesn't really matter what the type of reflection. Rotation 90 degrees counterclockwise. So if I take a triangle and then I rotate it 90 degrees, and I rotate it like that, let me do one that's a little bit more obvious. Yeah, I'll just keep that example. So let's say I take this triangle and I rotated it 90 degrees like that. It's the same size triangle. Like this is the same size as this. This is still the same size as that. And this is still the same size as that. So the size of the triangles didn't change. The sides are the same length. It just got rotated, right? So therefore, rotation preserves distance. Now, a dilation. We haven't talked about dilations yet, but dilations we'll talk about in the next chapter. In the chapter on similarity, rather. So dilation is when you stretch or you shrink something. Okay, so if you're dilating something with a scale factor of 3, you're making it 3 times bigger. So if I took this triangle let me say I took this little triangle, I made it 3 times bigger, right? That's a dilation with a scale factor of 3. So this is incorrect, right? This is changing the distance, so therefore it's not D. Reflection, yes, we talked about reflections. Reflections can preserve the distance. Dilation, scale factor of 1/2, it's taking something, a shape, and shrinking it by 1/2. So you're making it half as small. So it's not going to be that one. Okay, so it's anything that's translation, reflection, rotation is going to be your answer. All right, number 7. Triangle ABC is rotated 90 degrees counterclockwise about A. 90 degrees, so that's the first transformation. Translated, that's the second transformation. And then reflected along the x-axis, that's their third transformation. What are the coordinates? Let's write down the transformations for the rule for the transformation. So the rule for rotating 90 degrees counterclockwise is negative yx. The rule for translations, they give you the rule, it's negative 2, 3. So let me just write it out. So the rule for the translation is x minus 2, y plus 3. So you subtract 2 from the x and add 3 to the y. And then the rule for the third transformation, if I'm going to reflect along the x-axis, that means the y coordinate is going to change. So there you go. All right, so let's apply those rules to A, B, and C. Okay, so we got A, which is the coordinates A are 1, 1, right here. Coordinates of B are 3, 2. And C is 2, 4. So let's apply rule number 1. So if I apply rule number 1, I switch it and then put a negative on the first. Switch it, put a negative on the first. Switch it, put a negative on the first. All right, now I'm going to do the second transformation to both. So I'm going to subtract 2 and then add 3, right? So negative 1 minus 2 is negative 3. 1 plus 3 is 4. Negative 2 minus 2 is negative 4. 3 plus 3 is 6. That's going to be A double prime, B double prime, and we got C double prime. Negative 4 minus 2 is negative 6. 2 plus 3 is 5. All right, now we're going to do the final transformation. So this is A triple prime, B triple prime, C triple prime. So now we're going to do the third transformation. So that means we got to do, we just put a negative on the y. So negative 3, negative 4, negative 4, negative 6, negative 6, negative 5. Again, just putting a negative on the y coordinate. And that's it. That's your coordinates. Of course, we can graph it if we want to, but we don't have to. All right. Okay, so that's it for that one. So let's look at number 8. Select all compositions of transformations that would map triangle ABC onto A prime, B prime, C prime. So we need to select all of them that take us from here to there. All right, that's what we want. So let's see if A is right. Reflection in the x-axis followed by reflection in the y-axis. Okay, so remember the rule for reflection in the x-axis. So x-axis, the rule for reflection is that the y-coordinate changes, because that's what we did over here, right? Reflection in the x-axis, the y-coordinate changes. And then the reflection in the y-axis, the x-coordinate changes. Okay, so then basically put a negative in the y coordinate and then put a negative on the x coordinate. So if I do B, or let's do the coordinates A. So the coordinates of A are 1, 2, 3, 4, 5, and -1. So -5, -1. So then if I apply the first transformation, I get put a negative on the y, but it's already negative, so it becomes positive. And then for the second transformation, put a negative on the x. It's already negative, so it turns positive. So it's 5, 1. So A, 1, 2, 3, 4, 5, 1. So that looks good so far. That's 5, 1. Now if I do that for B, let's test it for one more. So B is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. So then if I do the first transformation, it's 5, -8, and then -5, -8. So for the second transformation, and that is -5, -8, right? So that's good. So this looks good. So A looks correct so far. We got to select all of them though. So we can't just be done there. So let's do a reflection in the x-axis followed by rotation 270 about the origin. We know the rotation for x-axis. Let's do the formula for rotation about the origin. 270 clockwise. So 270 clockwise is 1, 2, 3. So it's going to be, the rule is going to be -yx. All right, so then if I apply the rule to A is -5, -1. So first I'm going to do the reflection in the x. So I'm going to put a negative on the y, which it's already negative, so now it turns +1. Follow that up with a rotation. So let's use this rule. So switch the coordinates and then put a negative on the first one. So I got -1, -5. Is that correct though? No, -1, -5 is like over here. So nope, that's not correct. So it cannot be B. All right, let's do reflection and y equals -x, and then a rotation 90 degrees clockwise. Okay, the rule for, let's write down the rule for y equals -x. I'll put it over here. It's xy goes to, the rule for y equals -x is you switch the coordinates and put a negative. Okay, and then we got the rule for 90 degrees clockwise is xy goes to y -x. Okay, so those are your two rules. So let's apply that to A, -5, -1. And okay, so let's use the first rule. You switch the coordinates and put negatives on both of them. So basically this becomes 1, 5. So I switch it and then I put negatives. And then the second transformation, I switch it again, and then I put a negative on the second one. So I switch it again, put a negative on the second one. So that's 5, -1 when I switch it. So is that correct? 1, 2, 3, 4, 5. No. 5, -1 is over here. So it's not correct. All right, so it cannot be C. Let's do a rotation 180 degrees. So the rule for that is just put negatives on x and y. Okay, so let's do that. So A, if I do the transformation for 180, just put negatives on both coordinates. So it becomes 5, 1. And in the second transformation, I'm going to add 4 and then subtract 2. So 5 plus 4 is 9, and then -2 plus 1 is -1. Is that the correct coordinate for A? Definitely not, because that's going to put A over here. So definitely not that one. Maybe there is only one answer. I don't know. Let's see. It says select all, so there might be a minimum one. So reflection y equals x followed by reflection and y equals -x. Okay, so the rule for y equals y equals x is you switch the coordinates. The rule for y equals -x, if you recall, is you switch them and put negatives. So this might be it. So let's see. So if I do the first one, I just switch them. Then if I do the second one, I switch them back. I switch them according to the rule, and then put negatives on both of them. Okay. So if I do that, it's going to be positive 5, positive 1. Is that true? Positive 5, positive 1. Yes. So it looks like it works for A. And if you do it for B, it should work as well. So that should be your answer. So you have A and B. Or A and E, sorry. A and E. All right, now we're in chapter 5. So that was chapter 4. Let's look at stuff for chapter 5. Find the measure of each numbered angle. All right, so lesson 5.1 is about triangle angle sum theorem and exterior angle theorem. So remember that the angles in a triangle add up to 180 degrees, things like that. All right, so here we got vertical angles. When you see an X like that, remember, think vertical angles, okay? So 1 and 2, those are vertical angles. They have to be congruent. All right, so we know that we can get angle 1 because we got a triangle here and the angles add up to 180 degrees, okay? So we got 66 plus 58 plus measure of angle 1 equals 180, okay? And then 66 plus 58 is 124. So measure angle 1 is 180 minus 124, which is 56 degrees. Okay, so now we know this is 56 degrees, which means that this is 56 degrees. Okay, and now we can use triangle angle sum theorem to get angle 3. All right, so we know that 56 plus 50 plus angle 3 equals 180. And so the measure of angle 3 is 180 minus, if I add this, it's 106. So then it has to be 74 degrees. Let me just box my answers. So this is angle 3, and this is angle 1. All right, that takes care of that one. Notice how I show my work. Part B. So for part B, notice that we got a triangle here, and a triangle adds up to 180 degrees, right? So that's what we're going to do first. We're going to try to get angle 2. So triangle angle sum theorem for the triangle on the left. So we got 80 plus 35 plus angle 2 plus 36, okay? So remember, we have to combine these two angles. And this is not degrees. This is angle 2. We need to find it. This is in degrees, okay? So this right here is angle 2 plus 35 degrees. So let me just, you don't have to circle them, but I'm just going to circle them for now so you know which one I'm referring to. All right, so we got 80 degrees plus 36 plus 35 degrees plus the measure of angle 2 is 180. Okay, and then we can get angle 2 now from that. All right, so the measure of angle 2, if I add this, let's add that together. So let's add, let me just do that here just so that I don't make a mistake. So 151. All right, so it's going to be 180 minus 151, which is 29 degrees. Okay, so now I know this is 29 degrees. All right, this is what we wanted. But we also want to get angle 1 and angle 3. Now for angle 1, we know that there's a triangle here, so I can use triangle angle sum theorem to get that. Okay, so we got, so let me just circle the 1 so you know what I'm referring to. All right, so we got 36 plus 35 plus measure of angle 1 equals 180. This adds to 71. So the measure of angle 1 equals 180 minus 71, which is equal to 109. All All right. So now we know this is 109. Now there are a couple ways you can answer to get angle 3. First is, well, first off, we know we can use this triangle to get that. I'm sorry, we can use this triangle to get that, to get angle 3. So this is called the triangle exterior angle theorem. And what that states is that if I have an exterior angle, this angle 3 is an exterior angle because it's on the outside of the triangle. So notice I have the triangle here and I have this little angle that sticks out, right? So according to the theorem, to get the exterior angle, you have to add the 2 remote interior angles. So we have to add the 2 angles that are farthest away. The 2 angles that are farthest away from 3 are 35 and 36. Okay, so to get angle 3, I just have to add 35 plus 36, which is equal to 71 degrees. Another way that so that's called the exterior angle theorem. Another way to do this is we know that angle 3 and angle 1 are a linear pair. And they add it to 180. And so you can also say, okay, well, you can also say, or you can say 180 minus 109 is going to give me 71 because they're a linear pair. They add it to 180. So either way, you can see that, you can clearly see you get the same answer. Okay, so either one is fine. Okay, so now we know the angles. Let me leave that like that. Okay, so now we know all the angles. So now let's move on to the next question. All right, so lesson 5.2, if a series of rigid transformations maps triangle ABC onto, there's a typo there. The triangle should go over here. Triangle MRS, write down the length of each side. Okay, so here's the original triangle ABC, and it says it maps it onto MRS. So they're basically saying that triangle ABC is congruent to triangle MRS. That's basically what they're saying, because rigid transformations do not change the length, so it makes it congruent. And therefore, AB has to be congruent to MR, right? And so that means MR must be equal to ABC. And therefore MR, and we know ABC is 6, right? So let me just write this out. So I'm going to say, okay, MR is, or AB is congruent to MR. And we can see from the statement, BC is congruent to RS, right? So BC is congruent to RS. And then the last one, we can see from the statement, AC is congruent to MS. Okay, so now, if AC is 15, then MS is 15, by definition of congruence. If BC is if AB is congruent to MR, then AB is equal to MR. So AB is 6, so MR is 6. And then the last one, BC is 8, so RS is 8. And that's it. Pretty easy. All right, so now we're in lessons 3, 4, and 5. So we're going to introduce a couple of proofs for these guys, and then we're going to use a couple of, so we'll do a couple of other ones for SAS. So we just got a few questions for this, but I did want to include a couple of proofs, because there's going to be at least one proof question on the test for Chapter 5. Okay, so here we got a triangle. It says DE is parallel to FG, so this is the parallel symbol. Angle E is congruent to angle G, so that's written there already. And so they're given. So write down the given statements, right? The line segment DE is parallel to the line segment FG. The second is a given statement as well. The angle E is congruent to angle G. All right, now the third statement, we know that we're trying to prove this was SSS, SAS, that kind of stuff. So notice that this side right here is congruent to itself, so by reflexive property. So we're going to probably use that. And we also know that, and so far what we have is angle and side, right? Because we have the reflexive one. So let's go ahead and do the reflexive one. DF is congruent to DF by reflexive property of congruence. And then, so now we got A and S. So we want to prove it with, one of these. So far, since we got an A and S, we can use SAS, but we don't have a third side. So that probably eliminates SAS. And we don't have any really sides except for one side. So it can't be SSS. We have to prove it with AAS or ASA. Now we can't do it. We can't prove it with ASA because we would have to know two angles, and we would have to know an angle and a side between the two angles, basically. But we can prove this with AAS if we know another angle, right? Either angle D or angle F. Okay, and I claim that we actually do know those angles. So I claim that this angle right here is congruent to this angle. Why is that? Well, because we have parallel lines, and parallel lines cut by a transversal, you think sandwich model, right? And then in this case, these two blue angles are alternate interior angles. So we can say that angle D, or angle EDF is congruent to angle DFG. And that's by alternate interior angles theorem. Okay, there you go. And now we have AAS, right? They're congruent by AAS. All right, so we're going to say triangle. Okay, so I think the video paused, so I want to make sure that I cover everything, okay, so that we've done so far. Okay, so far we have the two given statements. I'm not sure why the video paused, so that's why I'm just going to do a quick recap. So we got the two given statements, and then we have the reflexive one, DF congruent to DF, right? And that gives us a side. So far we got angle side. And then we said that these two blue angles are congruent, alternate interior angles, because we got a sandwich model because we have two parallel lines cut by a transversal. And so that's alternate interior. So that gives us another angle. So now angle, angle, side, the two triangles are congruent by angle, angle, side. And then now because the two triangles are congruent, we can state, we can now say that, let me use another color. We can now say that DG is congruent to EF. We can say that any two parts that match up or correspond are congruent. And that is referred to as CPCTC. If we have two congruent triangles, then the corresponding parts must be congruent. CPCTC. Super duper important that you know CPCTC, okay? You have to know what that is. All right. Okay, so this one's write down the two given statements. Those are gimme points. We got HL is congruent to KL. And then the proof statement goes last, right? So that's an easy one too. All right. We've marked it on here. We said that GL is congruent to JL, KL is congruent to HL. So it's already written there. That means we got side and a side. Can we prove it with anything else? Well, yes, we have ourselves some vertical angles here, right? So an X, that means vertical angles. So we can say that this is congruent to this, right? And that gives us another angle. So it gives us side, angle, side. So we got vertical angles. All right, so angle GLH is congruent to angle KLJ. And that's vertical angles theorem. All right, and then we can go to next one. We can say that they're congruent by side angle side. So now we can say, okay, triangle GLH is congruent to triangle. Now remember, no marks. So actually we're going from G to L, which is 1 mark here, and then from L to H, which is 2 marks. Okay, so that means we got to start with J. 1 mark, then 2 marks. Okay, so it's triangle J LK. Here the order matters. When you do triangle congruence theorem, statements, the order matters. And that was by side angle side. All right, let me zoom in a little bit there. Okay, and then the proof statement we wrote down. So why is that true? Well, because the triangles are congruent, that means that the 2 corresponding parts must be congruent. That's CP, CTC. All right, and that's the end of the proofs, okay? So again, remember that CP, CTC for the test. And of course, remember the other stuff, but definitely don't forget that part. All right, let's look at number 13. Which additional statements are required to prove triangle ABC is congruent to triangle MNP if angle A is congruent to angle M by using the SAS postulate, AAS postulate, and ASA? Okay, so let's just draw 2 triangles. We got triangle A, B, C, and that should match up with triangle MNP. Now they said angle A is congruent to angle M. That's what they said. Okay. Therefore, we got ourselves an angle, right? So how do I prove it with side angle side? So if I or what do I need to establish congruence? So if I need SAS, that means I would need these 2 sides, right? So I would need to know that AB is congruent to MN. I would need to know that. I'm not going to put it on the picture though. All right, so I would need to know that AB is congruent to MN. That would be my first S. And I would need to know that AC is the same as MP. So those are the 2 additional things that I need to be able to prove it with SAS. Now for AAS, I would need to know, okay, I got an angle here. I would need to know either angle C or angle B is congruent to angle P or angle N, right? And then I would need to know a side, okay? Let me just, maybe I'll draw it for this one. I'll draw it for this one. So for this one, A, B, C. Yeah, I guess I could draw individually. I'll draw for all of them. All right, so here I needed to know those 2, right? Now for AAS, I'm gonna do a picture for AAS now. This is the answer for this one, so let me just box that. Okay, so we got A, B, C. This is congruent to this. Okay, so for AAS, I could either do, I would need to know this is congruent to this, and then maybe this is congruent to this, and that would be AAS, right? So angle, side. Angle, side. So I would need to know, okay, so I could either know angle B is congruent to angle N. This is the first case. And I would need to know BC is congruent to NP. Or the other case, I could find out this angle, and that would be AA. And then I can get this angle and this side, AAS. Or I can even do the other side, AAS here, right? So there's a lot of answers for this one, okay? So for AAS postulate, a lot of answers, okay? Or I can know angle C is congruent to angle P. and then I can know NP is congruent to BC. Okay, those are just 2 of 4 possible answers. Okay, you can give 4 answers for that one. And then ASA. So ASA, we know that these were congruent, so that means ASA. So we could figure out AB is congruent to MN. And then angle B is congruent to angle N, or we can do this, angle, side, angle, angle, side, angle, right? So we could say that AC, let me do 2 here, say, and I'll do 3 here. So we say AC is congruent to MP, or angle C is congruent to angle P. Those are 2 possible answers. You only have to list one of them, but I listed 2 here and then 2 for AAS. Now for SAS, for sure, there's only one way to do that. Okay. All right. So 5.6, in an A-frame house, that's your roof, right, with A-frame. The roof extends to the ground level. So, so let's say this is the ground on the bottom here. Each side of the roof meets the ground at a 72-degree angle. Okay, so each side meets the ground at 72 degrees. And then we just have to figure out, okay, well, what is the angle where the 2 sides of the roof meet? Well, that's this top angle right here, right? So then remember, this adds up to 180 degrees by triangle angle sum theorem. So we got x plus 72 equals 180. So we got x plus 144 equals 180. So just subtract 144 on both sides. So we get 46 degrees, or 36 degrees. That's it. Pretty easy. All right, lesson 7. Use coordinate geometry to determine the type of triangle formed below. Select all that apply. All right, really easy. So for this one, you have to just count. Okay, so we got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so the length of AB and AC are both the same. Okay, so AB has to be congruent to AC. So let me just do that in another color. So we got AB is congruent to AC because they have the same numbers, right? And let me just show you how to get the distance formula. So to get the distance, so you use those 2 numbers. So we got 1 squared plus 5 squared. And that is the same thing as AC. The 5 times 5 is 25. 1 times 1 is 6. 1 times 1 is 1, and then add those up to get 26. So these are clearly the same number, the same length. And then let's check BC. Okay, so count it. How much you need to go down and over? 1, 2, 3, 4. This one's 1, 2, 3, 4, 5, 6. Okay. So we got the square root of 4 squared plus 6 squared. 4 times 4 is 16. 6 times 6 is 36. So if I add those, I get square root of 52, which is definitely not the same as that, right? So those are not congruent. So that means since we have 2 sides that are congruent, the answer is isosceles. Okay. If you wanted to, if you had all 3 sides congruent, it would be equilateral. If none of the sides are congruent, that would be scaling. Okay, so just select the appropriate answer. So just isosceles. All right, number 16. What are the coordinates of the midpoint of each side? All right, so the formula for midpoint is x1 plus x2 divided by 2, y1 plus y2 divided by 2. The formula for midpoint is on your formula sheet, so you don't have to memorize that. Okay, so if I want to get the midpoint of side of QP, I need to, let me do the work for this. So for QP, we have the x coordinates for Q and P are 2b and 0. So 2b plus 0 divided by 2. The y coordinates for QP are 2c and 0. So 2c plus 0 divided by 2. Remember that 2b plus 0 is just 2b. And then 2c plus 0 is just 2c. And then 2 divided by 2 is 1. So this cancels. And so does this. So that gives me b comma c. All right, so the midpoint of QP is b comma c. All right, let's do QR. So the x coordinates for Q and R are 2b and 2d. Then we've got to divide that by 2. The y coordinates are 2c and 0. And notice that these 2's actually cancel out because they're all the same. And then remember that 2c plus 0 is just going to be 2c divided by 2. So we can ignore the 0 there, right? And then 2 divided by 2 cancels. So we're left with b plus d and then c. All right, and then side OX. So we got side OX. So you add the x coordinates, so that's 2d plus 0 divided by 2, and then we got 0 plus 0 is divided by 2. 0 plus 0 divided by 2 is just 0. And then 2d plus 0 is 2d, and then 2d divided by 2, well, the 2's cancel. So we get d comma 0. And that's it. And those are the coordinates of the midpoints of each side. All right, so now let's do, so now we're done with chapter 4. There's a few questions that are called spiral review questions that you need to know how to do, okay? So that are on the test. And they relate to perpendicular lines and things like that. All right, so how would one, so looking at this triangle, how would one find that AC is perpendicular to AB? Perpendicular means it meets at a right angle, okay? So select all that apply. All right, so we want to find that this is perpendicular to this. So we want to show that that's a right angle. So we need to show that that's a right angle. How do we show that that's perpendicular? Well, one way to do that is to notice that these are two lines, right? And remember that if you have a line with a slope, let's just do a quick example. So if I know, let's do the slope of A. If I know that the slope of one of the lines is 2/3, this is slope. Let's just say if one of the slopes is 2/3, then the other slope has to be -3/2. You have to switch it and then flip it, or flip it and then switch the sign from positive to negative, or negative to positive. So if I have two slopes, one of them is 2/3, the other one's -3/2, then they must be perpendicular to two lines. So that's one way. In other words, if I multiply the two slopes, I get -1. Okay, so that's one test for perpendicular to see if you had a right angle. Okay, so that's what we got to do. Find the slopes of AB and AC. If the product of the slopes is -1, then the sides meet in a right angle. That's exactly what I was just saying. So if you multiply the two slopes and you get -1, then they have to meet at a right angle. Okay, we want to select all that apply. Find the slopes of AB and AC. If the product of the slopes is 1, then the sides meet in a right angle. No, it's not 1, it has to be -1. All right, find the slopes of AB and BC. If the slope of AB is the opposite of the slope of BC, then the sides meet in a right angle. No, it's not. It can't just be opposite, right? It has to be opposite and flipped. So see, these are opposite in sign, but they also have to be flipped. Okay, so it's not B or C. The next way that you can do this is if we want to prove that this is a right angle here, then what we can do is we can use the Pythagorean theorem, the converse of the Pythagorean theorem. Okay, so the converse of the Pythagorean theorem, let me write this out here, the converse of the Pythagorean theorem. states that, let's call this A, B, and C, okay? Remember the Pythagorean theorem states that if you have if you have a right triangle, then A squared plus B squared equals C squared, right? It also, if I reverse it, it says the converse of the Pythagorean theorem states that if A squared plus B squared equals C squared, then that implies that the triangle is right, is a right triangle. Okay, so that's how we prove right triangles, is if this works, then we can find it, right? So in other words, so let's look at here. Find AB, BC, and AC. If AB plus AC equals BC, then, or A squared plus B squared equals BC squared, then the sides meet in a right angle. So is that true? Well, it says here, yeah, AB squared plus AC squared equals BC squared. Yeah, that's what they're talking about. A squared plus B squared equals C squared. That's the same thing that we were just talking about. So that's got to be that one. All right, so then the next one, AB, BC, and AC. If AB plus BC equals AC, then the sides meet in a right angle. No, right? It has to be squared for the Pythagorean theorem. So it's not E. So it's got to be A and D. All right, and here's how easy it is to prove perpendicular. This is it. This is it for that question. But I did want to show you. Let's go ahead and see if they're perpendicular or not. Okay, while we're at it. Okay, so the slope for AC. Let's do the slope real quick. So 1, 1, 2, 3, 4, 5. It goes up 1 and over 5. So the slope for AC is 1 over 5. Now let's do the slope for AB. 1 to the right. And 1 to the right, and let's try it again. It wasn't letting me write on here. Hold on. For some reason, it's not letting me write on here. It's letting me do this, but it's not letting me write. So I'm gonna double check this. Okay, there you go. Now it's letting me write. For some reason, it wasn't letting me write. Okay, so here we got 1 to the right and 5 down. So down is negative. Okay, so we got to the right and down -5. So the slope for AB is rise over run. So rise is -5, is going down 5, and over 1. So then if I look at these, well, look, it looks switched and opposite sign. This is positive, this is negative. And therefore, this has to be a right angle. Okay, that's how we prove it with the slopes. Okay, that's one way, one of the ways to do it. The other way is with the Pythagorean theorem converse. All right, so number 18. Select all the equations that represent a line that is perpendicular. That means crosses at a 90-degree angle. That means the slopes are flipped and switched, or this opposite sign, with the equation y equals 3x minus 1. All right, so remember, y equals mx plus b. M is the slope. And we know that y is equal to 3x minus 1, right? And so this has to be the slope, or m, okay? Now, for it to be perpendicular, remember what we talked about, the slopes, if one of the slopes is 3 over invisible 1, which the slope is 3, then the other slope that's perpendicular has to be flipped and opposite in sign, so from positive to negative, okay? So -1/3. That's what makes it perpendicular. All right, so then the new equation of the new line has to be -1/3 x plus b. Okay, so that's already telling you that, yeah, okay, so it has to be -1/3 x plus something. B could be any number, by the way. So b could be 8, so that's good. So b is correct. It can't be a because it says 1/3 x. It has to be -1/3. So it can't be a. Now, these are tricky because what we had to do for these is we had to solve for y, because right now y is not by itself, okay? And then if we get -1/3 x, then we should be okay. So let's look at the part C, the equation in part C. So let's solve for y. Remember, so that means we got to get rid of x so that we can get y by itself. So we get 3y equals negative x plus 9. We can't combine 8x and 9, so we just put them side by side. Then we're going to divide by 3 on both sides. Divide everything by 3. And we get y equals, remember this is invisible 1 here, so this is actually technically negative 1/3 x. And 9 divided by 3 is 3. There's my negative 1/3, right? So that means it has to be perpendicular. So this is true. Let's test D and see if that's true. Again, since we got to get rid of this x and it's negative, so I'm going to add it. That's the only way to get rid of that. Right there, we get 3y equals x minus 6. Positive x minus 6, right? And then divide by 3 on both sides. Okay, so we got y equals, there's an invisible 1 here, so this is technically 1/3 x. 6 divided by 3 is 2. I have positive 1/3, right? Not negative 1/3, so it cannot be that. Okay, has to be negative 1/3, all right? And then let's test the last one. Negative x minus 3y equals negative 12. All right, so let's solve for y, get rid of this x. So we're gonna add it to both sides. Then we're gonna divide by negative 3, right? We gotta get rid of that negative 3. So we gotta divide negative 3. So we get, there's an invisible 1 here. So this is actually negative 1/3. And negative 12 divided by negative 3 is positive 4. Okay, well, there's that negative 1/3 that we wanted, right? And therefore, it has to be perpendicular. So this is the right answer. So we got 3 answers here, B, C, and E. All right, guys, that's going to do it for the video. I hope you found this useful and informative, as usual. I'll see you in the next one.